This is the oxygen gas sensor. It's used in several of our lab books. It's used extensively in our biology series. So there's standard biology, advanced biology, the inquiry biology book. And it measures the concentration of oxygen gas in the air. It's not for dissolved oxygen, so you do not put this into a liquid. We do have a dissolved oxygen sensor, but it's not this one. And the way this works, it is a chemical half cell, and it measures the concentration 0 to 27% of oxygen. And the oxygen has to go through a membrane here at the bottom. So it diffuses through there, and it can measure that concentration. One thing about this sensor is that you need to store it vertically. It comes in this box that says this side up, and the sensor is in the box in that orientation. And it's important that you do store it that way. The membrane down here, there's a gel that needs to stay across the membrane. Otherwise, you could damage it if you stored it for long term on its side there. So it's important to be able to do that. It is possible to calibrate the sensor, though you probably don't have to. The sensor booklet will tell you how to go about doing that. Now, the oxygen sensor comes with a Nalgene bottle, and so this bottle here is the standard one, would be in there. And so it comes with that one. Another option, though, is the BioChamber 250, and so this is the Nalgene bottle with an extra hole for a sensor to go in here. You might use this in conjunction with the CO2 sensor, so you could put the CO2 there and the oxygen in there if you wanted to. So I'm going to do a little data collection here, and so I have some peas that are germinating, and I'm going to put them in the bottle here, and we'll look at what happens to the oxygen level in this container as the peas are germinating. So to do this one, I'm going to put the lid on this one, and then I will put the peas inside the bottle. There we go. And I will put the oxygen sensor down into there, like that. And then plug in the sensor. And so when I do this, it's plugged it into channel 1 there, so it's giving me the oxygen right now in terms of percent. If you wanted to change those units, it's easy to do. You tap on the meter itself. You can go and do change units if you would like, so I could do parts per thousand, parts per million, or percent. I'll just leave it just like it is here. We have another option there. You can zero it, so you could have it read just the change in the oxygen value if you wanted to. Or the calibration that you possibly could do if you wanted to, but we'll just leave that just the way it is. Now, if you'll look to the upper right corner there, we'll see our default collection parameters. So the mode is time-based, meaning we're looking at the oxygen concentration as a function of time. The default rate is 1 sample per second, and the default duration is 300 seconds, or 5 minutes. So we're now ready to collect some data. And so I'm just going to hit collect. It slides over to the graph and is now going to collect data for 5 minutes. Our data is complete, and so we might want to be able to do some analysis here. If I look at my data, we see that this first part, it dropped fairly rapidly because I just put the sensor into the bottle and the peas had actually already been in there just a little bit. And so we saw this drop there. But this last part there looks like it kind of levels off and becomes a fairly linear portion. And what I would like to do is analyze this section of the data. And so I'm going to highlight that. And so I'm highlighting just that region of the graph. And that way when I do the curve fit, it will use just those data to calculate that. So I'll do curve fit, select there, and then there's little brackets there, and it's asking me that I want to try to use those data. So I'm going to go up to where it says choose fit, and tap choose fit, and I'll do a linear fit there. And looks like it I get a pretty nice little correlation there, so I hit OK. And so the slope of that section is displayed there, so it's telling me what the rate of change is for that piece of the graph. The oxygen sensor we've seen is quite useful. We used it for the P respiration here, for the cellular respiration. We could have used it for photosynthesis. We could have looked at the oxygen consumption by various animals. So anything that involves gaseous oxygen, it's definitely good for that. So it's used across the board, and it's definitely a great sensor to have.